This is a review then of the end of term test, term 4, the foundation tier version thereof. And the idea is to show you the things that you should have done and perhaps to show you a few things that you might have thought were okay but actually aren't, and to explain why. So the first part of the first question says complete this equation for photosynthesis. You've carbon dioxide plus something, which is water, plus energy from the sun, gives us glucose and oxygen. Now, you could have said the word water and the word oxygen, and that's just fine. If you're writing H2O, then you can't write, for example, H2O. Likewise with oxygen, it can't be O2. The 2 must be a subscript. It has to be down here, bottom right. It can't be up here, top right. Can't be up here, top right for the oxygen, and it does have to be a subscript. It has to be, as I said, you can't write just a normal 2 there. So that's that equation. What type of energy is used? Well, that is light or sunlight that you need there. Solar isn't enough. Sun isn't enough, sunshine isn't enough, and thermal or heat is just wrong. So it has to be either light or sunlight there. Which part of a plant absorbs the energy? Well, the answer is chloroplasts. You might have said chlorophyll. Chlorophyll is what chloroplasts contain. And it's okay. It's not really the right answer, but it's close enough. So chloroplast is what you want. You might have said chlorophyll, and that's okay. Part B, the graph shows the effect of the concentration of carbon dioxide on the rate of photosynthesis in a tomato plant or in tomato plants at 20 degrees centigrade. What is the maximum rate of photosynthesis? So this is a matter of reading off the graph. It doesn't get any higher than 20, and so the answer is 20 arbitrary units. That is to say, we're not really bothered about what the units are, but this is twice this is really all that's saying. So at point X, carbon dioxide is not a limiting factor. Suggest one factor that is limiting the rate of photosynthesis. You can see that no matter how much higher than this level of carbon dioxide here, no matter how much higher it goes, the rate of photosynthesis doesn't increase. So it isn't the carbon dioxide that's limiting here. But the things that might be limiting could be the temperature, it could be the light intensity or level or something like that. Those factors would limit the rate of photosynthesis, but the CO2 is not. A farmer plans to grow tomatoes in a large greenhouse. The concentration of carbon dioxide in the atmosphere is 0.04%. The farmer adds carbon dioxide to the greenhouse so that its concentration is 0.08%. Why would they do that? Well, if you look at the graph, you can see that 0.04 gives you a lower rate of photosynthesis than 0.08. So by adding the extra carbon dioxide, you increase the rate of growth of the tomato plants. So that would be the reason that the farmer would do it. Why would the farmer not use a higher concentration? Well, again, going back to the graph, you can see that higher than 0.08 doesn't actually give you any benefit. So it would not increase the rate of photosynthesis. There's the first reason. And if he did it anyway, it would cost him money for nothing. So those are the two reasons why he wouldn't do it. Question 2 then, the photograph below shows the lower surface of a leaf magnified 800 times. Name the hole A in the leaf. Well, that is the stoma. Name cell B. Well, I can just get rid of this so we can do that. Cell B is a guard cell, of course. So guard, the word cell is not necessary. That's why it's in brackets. So it is a guard cell. Cell B can lose or gain water. Complete the sentences. Choose the answers from the box. Water vapor can escape from the leaf through hole A. Well, that is by osmosis. I seem to be missing a bit of the question here. The next bit that you should have is transpiration. My apologies for that bit being missing. Part D. What factors increase the rate of water loss? Well, increase in temperature would do that. You're thinking about the things that would increase the rate of evaporation. And an increase in the wind speed would do that too. So if you think back to your physics, these are the things that would change the rate of evaporation, and this is what's actually happening with the leaf. So one reason why the movement of water in the plant is important, well, there's a number of things you might say here. You need your water for photosynthesis. You need it to bring mineral ions into the plant, through the plant. You might have talked about specific ions, nitrates, phosphates, potassium ions, for example, and translocation, the movement of molecules across barriers into cells, out of cells. That happens in solution, and so you need water for that too. So that's E. F then, the African baobab tree has no leaves for up to 9 months of the year. How does that help? Well, you would decrease the amount of transpiration going on. For one, you could say no transpiration. It's probably not true, but very little transpiration. And less water will be lost as a consequence. So there you have it. So you might have talked about decreased transpiration. You might have just said less water lost, which is because of the reduced transpiration. In G then, the photograph above is a photograph taken through a microscope. The image is magnified 800 times. One of the cells in the image has a width of 12 millimeters. Complete the following steps. Use the equation to work out the real width of the cell, which is the width of the image divided by the magnification. So you're going to do 12 divided by 800, and you're going to come up with the answer of 0.015. And then convert the real width of the cell, 0.015 millimeters, into micrometers or micrometers. Well, there's 1,000 times more micrometers or micrometers than there is millimeters. And so if you multiply that by 1,000, you'll get 15. Question 3. Use the correct answer from the box to complete each sentence. Water is transported from the roots to the stem by the xylem. Dissolved sugars are transported through the plant by the phloem. Movement of water through the plant is called transpiration. The transpiration stream. Water vapor moves out of the plant pores, and they are called stomata. Students investigated the effects of different conditions on water loss from leaves. The apparatus is shown in figure 1. Students set up 4 flasks A, B, C, and D. Used the same size of plant chute. Recorded the mass of the flask and plant chute at the start. Left each of them in different conditions. Recorded the mass of each flask and plant chute after 2 hours. Table 1 shows the conditions that A, B, C, and D were left in. So A and B had the same temperature. C and D had a different but the same temperature as each other. So the difference between A and B was the use of a fan. The difference between C and D was the use of a fan. Why did the student use cotton wool in each flask? Well, there are a number of possible reasons there. You have reducing or preventing evaporation. You have holding the plant in place. And you have preventing damage to the plant. The use of the same size plant chute, made the investigation fair. For 2 marks, why? Well, having the same size, of course, means that you'll have the same surface area or the same number of leaves, and you might have gone on to say why that's important. You'll have the water evaporating from the same surface area in each case. So what you're doing up here then, changing the temperature between these two and these two. And within each temperature, you have either fan or no fan. So you're looking at the effect of changing the temperature on the rate of water loss and whether or not adding a fan changes that. So there we have our results and what mass of water was lost by the plant in flask D. Well, the difference between the mass at the start and the mass at the end is 4.5 grams. Suggest what conclusion could be made? Well, I think you can see from the table quite clearly that increasing the temperature increases the rate of water loss or evaporation. So increased temperature or heat increases the rate of water loss or evaporation. So one or other of these terms in your sentence for 1 mark. Part 5, suggest what conclusion can be made about the effect of the fan. Well, if you look at the data, you can see that having that moving air also increases the rate of water loss or evaporation. You can see that the water loss with the fan at 20 degrees was greater than without, and the water loss with the fan at 35 degrees was greater than without, because you got an answer of 4.5 to go in here. So, part C then, student carried out another experiment at 20 degrees with no fan. The apparatus shown here in the experiment, the student recorded the mass of the flask and plant chute before removing the bag and doing it again, and what mass of water would be lost from the plant shoot in 2 hours? Well, the answer is 0.3 grams, of course. So, one reason for that answer, the plastic bag reduces the airflow around the leaves, or you could say that the air is humid around the leaves, and so there is less loss. Question 4 then, extracting copper from copper oxide. Which part of the method shows the reaction is exothermic? Letting the glow spread. If it's glowing, then it's clearly giving out energy. The equation for the reaction below is given. You have 1.30 grams of zinc fully reacting with 1.59 grams of copper oxide to produce 1.62 grams of zinc oxide. The mass of copper produced, well, you've got 1.3 plus 1.59, that's 2.89 grams over here, so you have to have 2.89 grams over here, and the copper makes up the difference. So the mass of copper then, 1.27 grams. That is to say, this plus this minus this, because these two added together would give you these two added together. So you would say 1.30 plus 1.59 minus 1.62 is the mass of the copper, which gives you 1.27. What is the physical state of the zinc oxide in the reaction? Well, you look here, you have an S on the end. That tells you that it is a solid. Which substance has been oxidized? Well, oxidation is the addition of oxygen. So it's obviously the zinc in this case. It's gone from being zinc to being zinc oxide. You also have the mnemonic. I can find a place to write it. You'll remember oil rig, I hope. It's not necessary in this case, but oxidation is the loss and reduction is the gain of electrons, or oxidation is the adding of oxygen, reduction is the removal of oxygen. Which type of reaction takes place when zinc reacts with copper oxide? Well, what's happening is that the zinc is knocking the copper out and taking its place. It is displacing the copper. It is a displacement reaction. Copper is a metal which structure represents the arrangement of atoms. Well, this clearly isn't just a metal. This is a compound of some kind because you have different kinds of atoms. And this is not the way metal atoms are arranged. And this is obviously a compound as well. So it's A. Now let me just make C and D not bold to make A stand out as being the right answer there. So A is the answer. Copper is used in electrical wiring. Well, one reason that it is used, obviously, is that it is a good electrical conductor, but it is also not prone to corrosion. It's easy to bend. Malleable, it is, but it's not relevant to this. Don't say that it doesn't rust because only iron rusts. Other metals corrode, but only iron rusts. You could also say that it's ductile, easily drawn into a wire. So, in the UK, 40% of the copper is recycled, 60% is obtained by mining. What's the simplest ratio of recycled to mining? 4 to 6, 3 to 2, or 2 to 3. There we go. What two advantages of recycling copper are there? Well, if you're not extracting it, you're going to use less energy. There's one obvious answer. And of course, if you're not extracting it, then you keep your copper ore. It'll last longer. Question 5, nearly there. What does an exothermic reaction mean? Well, it means that it transfers energy to the surroundings. We've already come across an exothermic reaction earlier. Which is the correct reaction profile? Well, if it's transferring energy to the surroundings, then it has less energy afterwards than it had before. So it has to be that one. And in C, the percentage of mass of oxygen in carbon dioxide is calculated by that equation. Calculate the percentage by mass of oxygen in carbon dioxide. Well, you have 2 atoms of oxygen times the relative atomic mass, which is 16. So you have 2 times 16 on the top line, divided by the relative molecular mass of carbon dioxide, which is, of course, 1 carbon and 2 oxygens. So you've got 32, 42, 48. So you've got 32 over 48, sorry, 44, which gives you 72.7. So you've got 1 mark for your 32. You've got 1 mark for your 44. And 1 mark for your 72.7. Balancing this chemical equation, well, you need to have two hydrogens for every 3 oxygens. So if you had 2 of those, you could make 2 of those. So there's your 4 hydrogens, 4 hydrogens, 4 oxygens, 2, and 2 is 4. Part E, 6.8 grams of hydrogen peroxide decomposes to just 3.6 grams of water. Calculate the mass of oxygen produced when 68 grams of hydrogen peroxide decomposes. Well, 3.2 grams of oxygen is produced from 6.8 grams of H2O2. And so if you've got 68 grams, you'll have 10 times as much. So you'll have 32 grams of oxygen. And that's the end of the review.